All right, let's go over example A. So finding the domain of the quotient of two functions. In this case, we had a function f right here and a function g right here. The domain of the function g is going to be all real numbers because although it's a rational function which will motivate us to take the denominator, 5x squared plus 1, set it all equal to 0 and solve all the way for x. But at the end, we have x cannot be equal to the square root of a negative number, which is against the rule. Because we should not have, we are not allowed to have any negative number underneath any even root. And the second reason is because if you graph out the denominator, the graph of the denominator, 5x squared plus 1, is actually a parabola that opens upward and has the lowest function value at positive 1 and go all the way to positive infinity. So really, because we don't have any restriction, we don't have any x value that needs to be excluded in the denominator, and we can plug in any x value into the numerator. The domain of the function g is actually all real numbers. But the function f is a little bit tricky because we have a square root function as part of the entire thing. So for the numerator, let's see. For the numerator, 1 minus x. Well, we had to take the inside of the radical, and we set it greater than or equal to 0. And that is true because every time we have a square root function, we want to make sure that underneath the radical, which is just, we want to make sure that the inside of the radical has to be at least 0 or above. So that's why we take 1 minus x and set it greater than or equal to 0. And solving for x, by adding x to both sides, we can tell right away that x has to be less than or equal to 1. So square root of x is going to be negative infinity. Oops, it's parentheses. All the way to positive 1, and it's a bracket at 1. But for the denominator, 3x plus 4 raised to the second power, but the domain is going to be all real number. So the domain of the denominator is all real numbers. But for the entire thing, for the entire function f, we gotta take the denominator and set it not equal to 0. And then we solve for x. Well, if we take a fourth root of both sides, we're going to have 3x plus 1 cannot be equal to 0. And solving for x, and of course you guys know how to do the algebra, you know that x cannot be equal to negative 1 over 3 in this case. So for the function f alone, I'm going to sketch a number line, and I'm going to find its domain. So for the numerator, let's see. The numerator is here. From negative infinity all the way up to and equals to 1. So maybe I'm put 1 right here. So this is the domain of numerator. For the domain of the denominator, it's going to be all real numbers right here. Domain of deno, which stands for denominator. But the domain of the entire function f has to include all of the x values in common of both domains of numerator and denominator, and all of the restrictions from both of the domains, and from the entire function, of course, which is x cannot be equal to negative 1/3. So maybe you're going to put negative 1/3 here. Well, for 1/3, I know that x cannot be equal to that because the entire function f is created out of two separate functions, the square root function and this polynomial function. The domain of the entire function f is again is going to be all of the x values in common of both of these domains and all of the restrictions of both of these domains and the entire function f overall. So we know that if we take a look at the shorter domain and we trace it all the way back to the number line, and maybe we can trace it all the way down here as well, we can see right away that all of the x values that both of these domains have in common are from negative infinity up to positive 1. But at the same time, we have the restriction that x cannot be equal to negative 1/3. So really, the domain of the entire function f is going to be from negative infinity up to negative 1/3, but not including negative 1/3. And then union, excluding negative 1/3 all the way to including 1. So parentheses as negative 1/3, but bracket at positive 1, because we're including positive 1. So this is the interval notation for the domain of f of x.